DH parameters are a topic that most students find confusing at first. And although there is an algorithm to assign frames, you will find there is still a fair amount of free choices to be made. It takes a bit of time and practice to learn, so don't worry if it seems hard right now. I'm going to show you how to derive the DH parameters for one common industrial robot called the Skara. Here is a schematic of the manipulator and its DH parameter table. An example of an actual Skara robot is the KUKA KR10. Skaras are characterized by having a revolute, revolute, prismatic, revolute, or RRPR structure with all joint axes being parallel. These manipulators are ideally suited for pick and place and fine assembly type tasks. One thing that will make your life much easier is to always draw the schematic in a configuration such that all the revolute joints have 0 angle and all prismatic joints have 0 displacement. Step 1 in our algorithm is to label all the joints from 1 to n. Here we go. 1, a revolute. 2, another revolute. 3, prismatic. And 4, revolute. Step 2 is to label all the links 0 to n. The fixed base link is always link 0. Here's link 0. 1. Notice that links do not have to be straight line segments. They can be curved or angled rigid bodies. 2, 3, and the end effector is number 4. Step 3 is to draw lines defining all joint axes. The dotted lines represent the joint axes. And to be clear, the axes of joints 3 and 4 are coincident. Step 4 is to define the common normals between joint axes. You can see that all the joint axes are in fact parallel, and joints 3 and 4 are coincident. So there are, in fact, infinitely many possibilities between each joint pair. As always, whenever there is freedom to choose, look for ways to minimize the number of non-zero DH parameters. Here's my choice for the common normal between joints 1 and 2, and for joints 2 and 3. So what about between links 0 and 1 and links 3 and 4? Both of these are special cases which I will discuss momentarily.